Alright, Assalamualaikum class. So today we'll be moving on into our last chapter. So this is chapter 10. So this chapter consists of two parts, which would be internet and mobile multimedia. So we'll be going into these two parts today. So first of all, I'll be going into internet, okay? So now, the question here asks, what is the purpose of using internet? All right, as we all know, we use internet to get information, right? We go on Google, we send emails, we go on YouTube. There are many things that you can do with internet. But basically, when we have internet, we are allowing computers to connect together, okay, in order for them to communicate and pass information to each other. All right, so basically the use of internet is to connect millions of computers together through a global network, meaning that when you are in internet, basically internet is a network, okay, where you have all these different computers all over the world that are connected together, allowing you to actually communicate and share resources across platforms all over the world. Okay, without the use of internet, you can't send email to your friend in the UK. Okay, if you don't have internet, you can't watch YouTube, because YouTube, the videos in there comes from videos all over the world. So basically we are connected through a global network when we are connected to an internet. Okay. Alright, so let's go into the history of internet. Okay, it started off in 1969, whereby it actually started off with a research. Okay, it started with a research by universities. Okay, so at that time there is this thing called the Cold War, if I'm not mistaken. Okay, so in order for the military to pass information to each other, okay, without loss of communication, because sometimes with telephone lines you can get cut off and things like that. So they said that they came up with this idea whereby they come up with a network. Okay, so at this point in 1969, there is only four computers that are connected through that network. So you have one in University of Utah, Stanford University, UCLA, and UCSB, if you can see there. Okay, so only these four computers are connected at this point. Okay, so with this four connection, they are able to pass information back and forth to each other. Okay, so this research network was actually funded by ARPA, which stands for Advanced Research Projects Agency of the US Defense Department. So basically this network is used for the military, okay, for them to pass information, how to I don't know, the strategies of the war, everything like that. All right, so this network at this point is called an ARPANET. Okay, and there were only four computers connected to this network. Okay, but as time goes on, by 1970s, ARPANET had grown steadily by embracing more than 30 universities, military sites, and government contractors. Okay, now, since universities are using this, okay, they are able to send emails, they are able to communicate better with each other. More and more universities have joined the network. There are different military sites that join the network, and even some other government contractors using the network. So the network from four computers has expanded to like a larger network. Okay, so as you can see here, all right, by 1986, okay, since the network has kind of gone out of hand, okay, and is not as secure anymore for the military to use, so the military created their own private network called MailNet, if I'm not mistaken. Okay, so this big network is now funded by NSFNet. Okay, not funded, they are funded by National Science Foundation, NSF, and this network has now become is now called NSFNet. Okay, so in order to support the larger network, okay, it consists of 5 huge computers with a speed of 56 kilobyte per second. Okay, so before this, the network was supported by supercomputers that doesn't have that much speed, which is 56 kilobyte per second. Okay, during ARPANET. But then when NSFNet took over, the network has been upgraded to 1.5 megabytes per second, the bandwidth. Okay, so it has gone higher, so meaning that it can support larger number of networks. So the network can now be expanded to more and more, basically more and more computers and things like that. Okay, so with NSFNet, since it's like the backbone, all right, this is how internet comes about. Okay, NSFNet is a foundation, and then you have more and more network connected to that NSFNet, so which has become the internet today. So by 2001, okay, there are more than 109 million domain hosts, and there are 407.1 million users connected to the internet. So the internet has become larger and larger till this day. Okay, which I don't know how many users are there, but I bet it'll be billions. Okay. All right. So what exactly is a network? Like I've said, internet is a network. Okay, so fundamentally, or basically, network is a cluster of computers whereby you have, when we talk about clusters, we have like a group, right? Okay, a group of computers, okay, that are linked together is known as a network. Okay, how it works is that, okay, one computer will act as a server to provide network services to the client computers of that network. All right. Just kind of give you like a better picture. Imagine you are in an office, okay, and you have only one printer, and inside the office there are many computers connected to that printer. Okay, basically that whole office is connected through a network, within a network. So since they are connected within a network, they all can share the same printer. All right, so they will have a server and a client that will kind of work around that network. So meaning that, for example, you have a printer and all these different computers are clients. Okay, you will have one computer which will act as a server, which will control which client will be using the printer and so on. You know, that it's kind of like that kind of idea. All right, so again, with a network, you can do many things. You can transfer files, you can email each other, you can print. Okay, there are many things that you can do when these computers are connected together. Okay. All right, so there are two basic type of computer networks. We have LAN and WAN. The difference between these two are basically the size of the network. Okay, so if the network is located in a smaller area, okay, it is called a LAN. Okay, LAN stands for local area network. It is where you have two or more computers connected together, sharing resources in a small geographic location. So the location is pretty small. For example, you have network inside your home, okay, where you have all these different computers connected together, all right, inside your home network, where you have that internet as well. Okay, that is known as a network. Okay, or within an office, okay, to share the same printer. Okay, that is known as a LAN as well. Okay, on the other hand, wide area network, which is WAN, all right, consists of two or more LANs which covers a wider geographic location, meaning that when you have a LAN, you have all these different computers connected within that one small network, right? When you have a WAN, you have all these different LANs, since each LAN have computers connected together. So all these different LANs, when they are connected together, they are known as a WAN. For example, UITM. Okay, UITM can have its own WAN, whereby I have a LAN in Segamat, and then I have a LAN in Shah Alam, and I have a LAN in, I don't know, in whatever. So when they are connected together, okay, through this wide coverage of area, it is known as a WAN. Okay, so this is suitable for large corporations or businesses. Basically, it is a network of networks. All right, you have networks, all these different networks connected inside one big network known as a WAN. All right, so again, what is internet? Internet is the largest wide area network in the world, connecting millions of computers together worldwide. Because in your house, you are connected within one LAN, but you can still connect to your friend in the UK, for example, then they are connected with their own LAN. All right, so you know that these computers are connected somehow globally. All right, so this is known as internet. It is the largest wide area network in the world. All right. Okay, so moving on. All right, IP address. IP address stands for Internet Protocol Address. It is a unique string of numbers separated by period or dot. Okay, so if you take a look at this here, okay, this is how an IP address looks like. Okay, now why do we need an IP address? Imagine if you notice, every single house, okay, where you live, you have your own address. Okay, why do we need an address? Because it identifies where your house is. So for example, if you want to send a letter to your friend, okay, you know where you can send that because you have their address. Okay, again, with computers, in order for them to send information to each other, okay, you need to know where the computer is located as well. So they have, each computer that are connected within a network will have their own IP address. Okay, for example, if you want to send an email from this computer to this computer, okay, you must know the IP address of this person's computer. All right, so basically IP address identifies each computer using the IP, which is Internet Protocol, to communicate over the internet. All right, an IP address has the format of 4 numbers separated by period. Each number can be from 0 to 255. If you take a look here, we have this IP address with this format whereby you will have periods, okay, the dots, okay. For before each dot, you have numbers. So we have 4 type of numbers, 1, 2, 3, 4. So each number can range from 0 until 255. All right. So if you see this, is known as an IP address. Okay, so domain name system, what is it? All right, domain name system, also known as DNS, is responsible in assigning names and addresses to computers linked to the internet. Okay, this allows internet addresses to be found by easy to remember names instead of using individual IP address. Now, let's say I want to send an email to my friend. Okay, so I remember her email as maybe lisa@gmail.com. Okay, I can remember that easily because it is in names. Okay, I can remember Gmail, I can remember lisa@.com, you know, it's quite easy for me to remember. But it can be difficult for me to remember IP address. Like I've said, each computer is identified by its own IP address. Now, how does domain name comes about? Okay, domain name helps us to remember where to send, where to locate each person's computer. All right, so this is done with the help of a domain name system. Okay, domain name system will assign names, okay, to the IP address of that computer. All right, it allows internet addresses to be found by easy to remember names instead of using IP numbers. So we don't have to remember all those numbers because it can be quite hard for us to even remember our phone number, right? Okay, let alone IP address, which has, you know, bigger numbers. Okay, so instead of us remembering the IP address, okay, we can just remember the domain name. Okay, the domain name is given by the domain name system. Okay, so if I show you this figure right here, all right, so let's say this is you. Okay, you want to, okay, whenever you want to open up a certain website, you use a browser. Okay, so the browser, when you open it up, let's say I want to open up google.com or wherever this website is. Okay, so you don't exactly know the IP address because you only know the domain name. So you type in the domain name, all right, within the browser. Then after that, okay, since you don't know the domain name, okay, your computer will contact the DNS server. Okay, because the DNS server will map and it will assign which IP address belongs to which domain name. Okay, so since you only know the domain name, so it contacts the DNS server, and the DNS server will return back the IP address to you. So now you know where the computer's IP address is. Okay, since you know that already, you can then contact the IP address of this particular computer. All right, since you're contacting, you want to open up google.com, so it will contact the Google server, for example. Okay, so you want to open it up, so you contact the Google server, so the Google server will give back the web page that you need. Okay, so basically this is how DNS work. Okay, it will map the domain name to the IP address, and that is how your computer can get a hold of the IP address. All right. Okay, so top level domain were established as categories to accommodate all users of the internet. If you take a look at your web pages, okay, every single web pages or websites inside your World Wide Web will have its top level domain. You have google.com, you have I don't know, MSU and uitm.edu.my. Okay, so every single .com, .edu, .gov, okay, it means something. Okay, every single website or URL is given its own categories. Okay, if you see .com, it means commercial entities. If you see .edu, it means that website is for universities, for colleges, for schools, etc. Okay, if it's for org, then maybe it's for non-government organization. Okay, you can even find two-letter country codes like .my, which stands for Malaysia, .uk, which stands for the UK. All right, so these are the top level domains which you can take a look at. All right. Okay, there's also a second level domain. So the second level domain is built up from the top level domain. It consists of different levels separated by a period or dot. If you take a look here, this is known as a URL. Okay, you have HTTP. HTTP is the protocol that you're using to open up your website. Okay, and then you have www, which stands for World Wide Web, and then you have example. Example here is a domain name. Okay, like I said earlier, .com is a top level domain. Okay, so when you have the dot and the one next to it is known as a second level domain. Okay, so .com is a top level. So if you have the dot, the next one next to it is called a second level domain. All right, so you also have country code. Like I've said, if you have .my, it means Malaysia. If you have .uk, then it means the UK. Okay, if you have, I don't know, SI, then it means Slovenia. All right, .eg, then it means Egypt. Okay, so each country will have their own country code. All right. Okay, now moving on. Next thing we have is a TCP/IP. All right. So whenever we want to communicate on the internet, we need to follow a certain protocol. Okay. Let's say you want to send an email to your friend. Okay, or you want to open up a website. Okay, certain website. Okay, when these are all communications within the internet. Okay, let's take an example where we want to send an email to our friend, for example. Okay, so in order for us to send the email to our friend, okay, we must have our where our source is, and we need to know where our destination is. Okay, so in order for us to communicate and send this information over, okay, to a different computer, we need to go through a thing called a TCP/IP. Okay, TCP/IP stands for Transmission Control Protocol and Internet Protocol. Okay, it's divided into two parts. All right, so these two are protocol which we must use in order for us to communicate. Right. So how it works is that, let's say you want to send an email. All right, so we have an email. So the first thing that that we'll go through first is a thing called the Transmission Control Protocol, which stands for TCP. Okay, so TCP, when a stream of data is sent over the internet by your computer, okay, let's say you want to send an email. All right, the TCP will break that email up, that data, into packets. Why? Because when we want to send data very fast, okay, we don't want to send it as bulk, okay, because that will be too heavy, because we need to go through different network, because you're traveling through different routers, different networks in order to get to your destination. Okay, so it needs to be fast, so that's why it breaks it up into packets. Okay, so when we break up into packets, all the data will be smaller, so it's easier for you to send those data a bit faster. All right, so each packet will contain the address of the IP address, okay, the sequence number, so which packet is which, okay, the error correction information, and a small piece of your data. So all of this will be divided up so that it can be sent easily, and it will be numbered so that whenever they are sent, who sends these packets? Okay, Internet Protocol, IP, is responsible in sending the packets to its destination. So once we have broken up into packets by the TCP, then the IP will take those packets and send it to the destination. Okay, and it will follow along a route, that may include many other computers acting as forwarders. As we all know, internet is very big. It consists of networks of networks of networks, so it will go through all these different networks in order to get to the destination. Okay, so who sends this? The IP will send it. All right. Okay, so now let's say if you want to connect to the internet, you can use any of these connections. Okay, you have dial-up connection, broadband connection, and wireless connection. Alright, if you take a look here, dial-up connection is an old technology where we don't really use it now. Okay, I don't know if you have experienced this before, but with dial-up connection, you will notice that it will have a modem. Okay, so this modem will be connected to a telephone line. But the thing here is the modem that is connected to that telephone line uses the same connection, meaning that you can't connect to the internet if you're using your phone. Okay, so let's say you're using your phone, you're using the internet, and suddenly someone picks up the phone, you will hear the really weird sound like something like that. All right, so because you can't use the same connection of the internet and the phone at the same time. Okay, so that is an old technology. Then comes broadband connection, where we have a modem. Okay, so right now we're using a modem connection, broadband or modem connection. All right, so let's say you subscribe to Unify or subscribe to Maxis, and they give you a modem and they set up at your house. Okay, the modem usually will be a digital subscriber line, DSL modem. Okay, so this modem is provided by your ISP, which is your Maxis, TM, you have Cellcom, whoever it is, which is the internet service provider. So ISP will provide internet access to you. All right, so this modem will then be connected to a phone line. All right, but with DSL modem, the connection is now, it has two connections, where if you use the phone, okay, you won't disturb the internet line, okay, because they are now two different connections. Okay, so when you have a modem, okay, ISP usually gives a modem with a built-in router or web. Okay, network router will network router or router, okay, it will route internet connections to all of devices, which will create a LAN. Okay, so let's say you have a router. Okay, a router allows your modem to connect to different devices, not only just one. Okay, basically instead, because with a modem, okay, if you only have one part, only one computer can be using that connection. But if you have a router, okay, it allows all these different computers inside your house to be connected to the same modem, so that everyone can use the modem. So since everyone is connected through that same network, this is known as a LAN. Right, so a router will also have a built-in web as well, which is a wireless access point. This generates Wi-Fi signal for internet connection. So this means that it doesn't necessarily, in order for you to connect to the internet, you need to have wires. Okay, so the wireless access point will give out Wi-Fi signal, allowing you to connect to that network and without the use of a wire. All right, so a web usually is attached to a router or a modem. Okay, so the internet service provider ISP allows you to connect to the internet. So basically, this is how your computer will be set up whenever you're using the internet. Okay, so let's talk about bandwidth. All right, by definition, bandwidth is how much data you can send from one computer to another in a given amount of time. So bandwidth is measured in bits per second, BPS. Okay, bandwidth is usually when we refer it to the speed of the internet, because it basically, bandwidth specifies how much data that you can send over the network within 1 second. Okay, the more data that you can send within 1 second, the faster your speed will be. So that is bandwidth. All right, the higher the bandwidth of your connection, the faster the transmission of your data. Kind of imagine if you have a road, the bigger the road, the more car that you can fit into that road. Right, the bigger the bandwidth, the faster your data can be transferred, because more data can be transferred at one time. Okay, therefore downloading and uploading time of your computer will be a lot quicker. All right, so low bandwidth modem connections are a bottleneck for sending multimedia across the internet, causing a network congestion. Okay, so usually whenever we have a bottleneck, imagine you have a bottle. Why we call it a bottleneck? Imagine you have a bottle. All right, bottle shapes like this, right? Okay, you have a lot of data to be sent. Okay, but your bandwidth is less, so there will be a bottleneck there, meaning that you want to fit a lot of data within one narrow neck. Right, so there will be a bottleneck causing network congestion. Okay, so whenever we have a bandwidth bottleneck, Okay, these are some tips or some consideration that you can do. All right, so before you transmit your data, you might want to compress your data. Compressing means you want to lessen your data. All right, when you compress your data, it will be a lot smaller, so it'll be faster for you to transfer your file. All right, also you can oblige the users to download the data only once. Okay, meaning that instead of you accessing the same data over and over again, okay, let's say you want to watch a movie. Okay, so your internet is slow. Instead of you waiting for you to stream, basically, instead of you waiting to stream that again and again every single time you open it, you can just download it. All right, download it once, then you can watch it afterwards. All right. And then next tip is design multimedia elements to be efficiently compact. Example, don't use a greater color depth than is absolutely necessary. So if you think that your user, okay, doesn't have a very good connection, then you might want to lessen the use of multimedia in there. Maybe less video, okay, less graphic, more text, for example, okay. And next tip would be design alternate low bandwidth and high bandwidth navigation path to accommodate all users. So this is a very good tip. I find that, I don't know if you noticed that, but with Facebook or Gmail, they provide different version of the software for users. For example, if you think that your internet is fast, you can use regular Facebook. But if you think that your internet is pretty slow, okay, you can use Facebook Lite. Okay, the versions are a bit different. With Facebook Lite, they uses less graphic, okay, more text, okay, so it'll be a lot lighter for the people who don't have much speed for the internet. All right. Okay, next it would be implement incremental streaming method. This allows data to be displayed without waiting for the entire data file to arrive. Implement incremental streaming method. Allow data to be displayed without waiting for the entire data file to arrive. Okay, so the next tip would be implement incremental streaming method. This allows data to be displayed without waiting for the entire data file to arrive. All right, so let's say you want to watch YouTube. Okay, YouTube uses streaming. Okay, so basically what streaming is, it will allow your let's say you want to watch a video. Okay, while you're watching it, it's downloading the file. Okay, so as you're watching it, you are okay. Alright, so the next tip would be implement incremental streaming method. It allows data to be displayed without waiting for the entire data file to arrive. Meaning that let's say you want to watch a video, okay, instead of you downloading the whole thing, if you think that your computer cannot handle that, okay, then you can use an incremental streaming method. For example, you upload it onto YouTube, allowing your users to watch the video using the streaming method. So while they're watching it, they're downloading it on the buffer. Okay, so so you don't have to wait for the entire file to be downloaded. Okay, while you're watching it, it's downloading it for you. Okay, so you can use streaming method as well when you have bandwidth bottleneck. Okay, so moving on to internet services. These are some common services provided by the internet. Okay, so within the internet, there are many various use. Okay, moving on to internet services. All right, so other than just opening up websites, okay, there are actually many services that the internet provides. So if you take a look here, okay, you have FTP. FTP is used to transfer files between computers. Let's say you want to create your own website, okay, you want to transfer from your computer to the server, then you can use FTP service. Okay, or if you want to open up website, okay, or web pages, it uses a protocol called HTTP. Okay, if you want to open up an email, so then it uses a services called POP. All right, depending on what you want to do on the internet, there are these different services which you can access and use. All right, so next thing we have is daemon. All right, daemon is a software located inside an internet server where it will implement internet service. Basically, daemons are agent programs that run in the background and wait to act on requests of internet services. So if you take a look here, okay, for example, let's say I use HTTP service. So HTTP service is used to open up websites, okay. So HTTP stands for Hypertext Transfer Protocol, all right. This is used to open up websites and web pages, okay. So let's say you want to open up google.com, okay. So you're contacting the Google server. So within that Google server, all right, when you're using a HTTP service, all right, an Apache HTTP daemon could be used. Okay, so this is one example of a daemon called Apache HTTP daemon. So this is a server program that waits for requests from client and responds to them by sending requested data to them. All right, so since within, if you want to communicate over the internet, we have client and you have server, right? Okay, so this daemon will reside at the server side and wait for the request from the client. So whenever the client wants to open up the website, then this daemon from the server will act on the request that the user wants or the user needs, okay, by sending those requested data to those client. All right, so with daemon, it supports services such as HTTP for World Wide Web, for emails, POP, for FTP, which is for exchanging files. So they will also have each their own daemon to basically waits for the request and send the data whenever needed. All right. Okay, next thing we have is MIME type. So this stands for Multi-Purpose Internet Mail Extension. This is a standard list of file name extensions. It identifies the format and purpose of the transmitted data so that the browser can open up the file with the proper extension or plugin. So whenever you want to open up or want to send multimedia files over the internet, so these are the extensions that you can use, which will be supported by the browser. Okay, for example, you want to send a video through an email, okay, maybe you can use .avi extension because .avi can be supported by the browser, or .mp4, all right. So the extension, okay, is known as the MIME types, all right. All right, moving on to the World Wide Web. By definition, a World Wide Web is a protocol for linking multiple documents located on computers anywhere within the internet. So basically, imagine, all right, a World Wide Web is a location. Basically, it is a protocol whereby inside there you will have all these different web pages that are connected together. All right. So whenever we want to open up a web page or website, we must connect to the World Wide Web first. Okay, because the World Wide Web protocol allows you to open up those web pages. All right. So because the World Wide Web links all those documents located on computers anywhere within the internet. So in order for you to open up a website which is located within the World Wide Web, okay, you need to use HTTP. Okay, HTTP stands for Hypertext Transfer Protocol. All right. So that's why whenever you have an URL, you have HTTP, which stands for the Hypertext Transfer Protocol. Then you have www.google.com. Okay, so in order for you to access google.com, okay, which is connected within the World Wide Web, so in order for you to access that, you need to use a HTTP, which is Hypertext Transfer Protocol. Okay, so HTTP provide rules for a simple transaction between two computers on the internet. Okay, so with HTTP, it allows you to connect or communicate from one computer to another, okay, by firstly establishing connection, then you request for that document to be sent, then that person will send back the document to you, then it will close the connection. All right, so this is all done by the Hypertext Transfer Protocol. All right, so with the World Wide Web, all right, the website or the web pages that was created must use the language called Hypertext Markup Language, which stands for HTML. All right, so this is a document format for presenting structured text mixed with inline images. So by using a web browser server, users can surf from documents to documents across the web. So basically, in simpler words, all right, within the World Wide Web, you have all these web pages. All right, these web pages needs to be written in HTML by basic. All right. In order for you to open up those web pages, okay, within the World Wide Web, all right, you need to use a browser such as Google Chrome, Safari, Mozilla Firefox, all right, to get from one pages to another, all right. So next we have is URL. So URL stands for Uniform Resource Locator. So it specifies where an identified resource is available and the mechanism for retrieving it. Basically, it is an address of a web page on the World Wide Web. So as we all know, all website, all web pages, okay, if we want to make it online, in order for us to allow users to access those web pages online, all right, it needs to be placed inside a server, all right. So for every server, okay, for every web pages that is located inside the server will have its own URL. Okay, if you want to access certain web page, you need to know the URL to open it up. Okay, it's kind of like that address as well. Okay, so if you take a look here, this is an example of URL. Okay, http www.davescomputertips.com/newsletter/2007-0915.php. Okay, if you take a look at the URL, okay, every single part of the URL will mean something. Okay, if you take a look at .php, meaning that this web page is written in PHP. Okay, if it's .html, then this web page is written in HTML. Okay, so the next after the dot, okay, we have the file name. So whenever this page was created, the page was renamed as this file name. Okay, so where is this page located? This page is located within this folder called newsletter. All right, so where is this folder located? This folder is located within this domain. All right, so whenever you have a domain, you also have a top level domain, okay, which is .com. So you know that this website is for commercial use, all right. So then you have the domain name, all right. And lastly, this web page must be accessed through a World Wide Web protocol and also a HTTP protocol. Okay. Alright, like I said, in order for you to create your websites or web pages, okay, you need to use a HTML. HTML stands for Hypertext Markup Language, okay? So this language is used to build and deliver uncomplicated static web page, alright? So whenever you build a web page, there are two types of web page that you can do. You can do a static web page and a dynamic web page. A static web page is something that whenever you refresh that web page, it stays the same. For example, let's say you have Wikipedia. Okay, no matter how many times you refresh that web page, the content of that web page will always be the same. So that is static web page. So to create that web page, only using HTML is enough. Okay, but if you create things like Facebook, Twitter, all right, so whenever you refresh your page, the data is dynamic. So meaning that the content will always be different every single time the user open it up. Okay, meaning dynamic, it is always changing. All right, so to create a dynamic web page, you can't rely on HTML alone. You might need to use things like PHP, JavaScript, etc. Okay, so those are the difference between the two. Okay, so whenever you design a web page, you must keep in mind of the interface. Okay, you must create a website that have a user-friendly interface that balances bandwidth deficits against user patience. If you think that your user has very low bandwidth, okay, then you might need to use less multimedia elements inside there. Okay, if you think that your user has higher bandwidth, then it's okay for you to put video inside there or to put like more images inside there. Okay, if the user has less bandwidth, then it'll be harder for them to load those elements within your web page. All right, so within the web, you also need to understand how to deliver multimedia content for HTML browsers, because sometimes, let's say you want to put in flash animation inside your web page. Okay, you must know that in order for users to open up that flash animation, they might need to install the Flash plugin. Right? So for every element, sometimes you need to require certain plugins to play or open it up. Okay. Okay, now, like I've said, whenever you are connected to an internet or to a network, there is this thing called a server and a client, all right? Whenever you are communicating with each other within the internet, okay, there is a thing called a web server and there is a thing called a client, all right? Web pages is located inside a web server. So a client is the user. So a client will use a browser to access those web pages that are located inside that server. Alright, so the workings of the web involves a communication between two computers, which are web server and client. So web server will deliver a file whenever a client asks for it. Okay, so keep in mind, web server will contain web pages. So client is the user will access those web pages from the server. All right. Now, web servers varies in strength and capacity. The response time of your connections to the web server will depend on the speed and capabilities of your computer and the software serving it and the bandwidth of the internet. So let's say the user wants to access those web pages. Let's say I want to open up youtube.com. All right. So how fast the user can access those data will actually depend on the computer as well as the software that is serving it. All right. Sometimes when you use Google Chrome and Mozilla, maybe Google Chrome can be a bit faster when we use Google Chrome. Okay, so depending on what you use, the response time of that connection can be affected as well. All right, and also of course the bandwidth of the internet. Okay, the faster the bandwidth, the faster that you can get the data from the server. All right, so the client, all right, will be using web browsers, okay, to access those web pages. Right, web browsers are applications that run on a user's computer. Okay, so it provides interactive graphical interface for searching, finding and viewing multimedia resources on the web. So when we use a web browser, it is easier for us to access those web pages because it provides an interface so that we can just click on and access those web pages really easily. Okay, so an example of web pages we have Internet Explorer, Google Chrome, Mozilla Firefox, etc. Next thing we have is search engines. All right, so search engines allows you to retrieve information in seconds by searching the entire public web. As we all know, within the World Wide Web, we have many web pages, right? So in order for us to access and search where we can find all those web pages, we can use search engines. Okay, so you have things like Yahoo and Google, and you have MSN. So there are many search engines that you can use. All right. So when it comes to creating websites, okay, you can use web page makers and site builders. Okay, so you have two types. We have HTML editors and HTML translator. Okay, so if you think that you can write your program from scratch easily, okay, you can just use HTML editors. All right, HTML editors allows you to write HTML codes by writing the markup of web page, meaning that you already know how to use HTML. Okay, so let's say you want to make something italic within the document. Okay, you know what markup tag to use, so you can just use HTML editor for that. All right, but if you don't have basic knowledge of HTML, or you can't write web pages using HTML, you can just use HTML translator, because HTML translator allows you to export a word process document with its text styles and layout converted to HTML tags. For example, if you take a look here, this is an example of a HTML translator. Okay, so you write, let's say, my favorite food, and the next part you want to make it a list. Okay, so this is how you want to present your data within your website. So if you click convert, okay, so it will convert this, what you see here, to an HTML file, which is written in HTML. So it's easier because it allows whatever that you write converted into HTML tags. So if you don't have HTML knowledge to create your website, then you can just use HTML translators. All right, lastly, we have plugins and delivery vehicles. All right, plugins allows users to view and interact with many types of documents and images. Like I've said, whenever you want to put something on the internet, there might be some plugins that is required to open it up, such as Flash animation. Okay, you might need to have a Flash plugin. All right, next thing we have helper applications or players. This will display or run files downloaded from the internet by your browser. So this is run separately outside the browser. Now, let's say because not everything can be opened or played by the browser. Okay, sometimes you might need other application or other helper application to help us play those files or open up those files. All right, so this is run separately outside the browser. For example, you have PDF. Okay, so let's say you download a PDF file. Okay, you will notice that the browser does not actually open up the PDF. Instead, it will use a helper application to open up that PDF file in a new tab, for example. Okay, all right, so if a page contains a multimedia element that cannot be viewed by the browser, you need to install the required plugin. It's usually included as hyperlinks. It will direct users to the site that has a missing plugin. So for example, let's say your computer cannot play that animation, okay, that flash animation, then sometimes that browser will provide a hyperlink. Okay, click here to download the flash plugin. Okay, this can happen as well within the browser, so it allows user to open up that to download that missing plugin. All right.